going to talk to you today about a little project I've been working on called Platypus. It sort of makes FFI a bit more practical, in my opinion. So just as an overview, FFI, or Foreign Functioning Interface, is a mechanism by which a program written in one programming language can call routines or make use of services written in another. And so if you've been doing Perl for any length of time, you probably know that we have one of those called XS. And it's okay if you want to do that and you're going to call C or C++, you can do that. In practice, though, FFI refers to calling a dynamic library a shared object written in a compiled language like C, Rust, Fortran, Pascal, whatever compiled language from a scripting or virtual machine language, so like Perl, Python, Ruby, Java, that kind of thing. Using libFFI, which is it's a separate project. They've done a lot of work to make sure that it works on just about any platform that you can think of. And we've actually had FFI available in some forms in CPAN for a long time, but the ones that I'm going to focus on are FFI Raw, which I used to implement some libarchive bindings, and Platypus, which addresses some of the issues that I had when I was writing those bindings. So FFI Raw is a CPAN library that allows you to create a Perl object that represents a function inside a dynamic library, shared object. So you give it the library name, the name of the function, and the function signature. Excuse me. And then you can call it using the call method. So this is a bit awkward. You have to, if you want somebody to use your bindings, you have to wrap that around some other interface. The big difference in the way Platypus works is it's an object-oriented interface, but now instead of the object representing the function, it represents the library. And you use the attach method to attach your functions into Perl space. So now this is the same code basically, except for I'm attaching the fdim function and calling it just like a regular Perl subroutine. And you can export this into your caller's namespace, and they can use it without even really knowing that they're using FFI or whatever. And this actually has some performance benefits, which I'll get into in a bit. So why would you want to use this instead of, like I said, we have XS, why wouldn't you want to use this? Well, it's a bit more portable, and this is a slide that I borrowed from a Ruby talk that somebody gave some years back. And basically in the Ruby world, they have multiple implementations of Ruby. And I showed this actually in DC Baltimore workshop, and somebody in the audience explained to me that this is actually small potatoes. They've got like way more versions of Ruby depending on the appropriateness of the environment. But the idea is that you can implement your application on one of these platforms, and it should work on any of them because they all provide the same FFI Ruby level interface. And the other way it's a bit more portable is I've actually taken Ruby FFI libraries that have been interesting, and I've re-implemented them in Perl, and that's pretty easy to do. I've even taken some of my libarchive stuff and ported it to Scala. So I think what I'm trying to say is the technique is applicable to more than just Perl, whereas I think Perl, if you're using XS, this is the Perl XS Manpage, and if you want to do serious stuff, you're going to become familiar with this, and it's a lot of reading to do, and it's not really applicable to anything but Perl. In fact, there's some other Manpages that you're going to have to look at. So it's up to you what you want to do. So the question that often people ask me is, well, is it fast enough? How does it perform? And it's a good question because obviously the current implementation of Platypus and FFI Raw are implemented using XS. So it is sort of an extra layer. There is going to be a little bit of overhead because of that. So I had three principles when I was building Platypus just to keep in mind, because the main thing is to make the thing easy to use. But to keep in mind, at the same time, to keep it relatively fast. One thing that I did was I'm attaching functions as Perl subroutines, which is what I showed you. It's an interface benefit. It actually turns out to be a big performance benefit as well, because there's no object-oriented overhead. I'm allocating memory on the stack where possible, because malloc can be expensive. And I wrote some benchmarks to test out as I make iterative changes to make sure that I'm not losing any losing any speed. And the results were pretty good. This is one benchmark that I ran. I ran a bunch, but they pretty much were very similar, just in terms of the actual times. But the Platypus version is, as you can see, it's about 12%, within 12% of the XS version. And just as a thought experiment, I also wrote an implementation using XS that was object-oriented. So it's essentially like the FFI Raw version, in that it sort of injects an extra object-oriented call. And it's much slower than the Platypus version. So it's kind of silly, though, right? It's like comparing apples and oranges. Object-oriented programming is not, FFI. But I just wanted to put it in there as a something to keep in mind. If you're saying that FFI is too slow and that you're never going to use it, you should also say that object-oriented programming is too slow and you shouldn't ever use it. Things are appropriate in the appropriate places, and if the thing can solve you some programmer time, it may be worth a few cycles. Benchmarks. So benchmarks, I think Mark Twain said that there are 3 types of benchmarks. 3 types of lies. I just gave away the joke. Lies, damn lies, and benchmarks. Sorry. But what about real applications? So Dylan ported his ZMQ FFI from FFI Raw to Platypus, which was great, because it gave us a real application to see how it performed. And he said that it was a huge improvement over the FFI Raw version. And he cited the ability to attach functions as sort of the killer feature of Platypus. He said that his version was about 10 times faster than the Python implementation, and his estimate was it was within about 30% of the XS implementation. Which may seem like a lot, maybe, but on the other hand, the C implementation was much faster than the XS implementation. So really, if raw performance is the only thing that you're going to consider, write it in C. So now that we've talked about performance, the next thing, I'm just going to do sort of vignettes here, little short subjects related to FFI. The next thing I want to talk about is records. So structured data, it's a common way of passing information in C. It sort of exposes your innards. It's kind of not a very nice way to pass around information, but it is sort of necessary if you're going to interface with C libraries. So in order to do that, I created an FFI Platypus record interface. And what it does is you specify a layout of the types that are names and types that are in the record, and then you can declare it as a type. And then when you're attaching the function, you can use that type as an argument type. And now my local time function will return one of these TM objects, and I can access the fields using accessor attributes. There's some other ways you can do this, but this is sort of the nice thing about this is it takes care of all the alignment issues and stuff for you, so it makes things simple. So records is just one area. I use it as an example of it's kind of one of the neat things that we've done. There's other things you have to deal with when you're talking to C. You have to deal with strings, pointers to integers like basic types, floats, that kind of thing. Arrays of those types, callbacks, and we also have custom types. So there's a lot of ways to deal with types that I don't actually see in a lot of other FFI implementations. So kind of neat. The other thing that I wanted to touch on is the foreign language support. This is something that I'm kind of excited about because I'm interested in other languages. But say you have a hot new compiled language called Kangaroo, and there's a library implemented in it called libskippy. So what you can do is you can create a foreign language plugin called FFI Platypus Lang Kangaroo, and this will define the types in the language and any name mangling that is going on. And then you can write your Skippy FFI without really having to worry about C, because you're not working in C anymore, you're working in Kangaroo. And so why not use Inline Kangaroo? Well, obviously it doesn't exist. It's a little bit harder to implement. You have to write a parser, right? Every inline language that you want to support, you basically have to almost re-implement the language itself. It's also XS under the hood, so there's extra layers to debug when something goes awry. It's also tied to the current implementation of Perl 5, which may or may not be a good thing. I've written a couple of these already. Excuse me. One is the Fortran, and as you can see here, when I attach the add function, I'm using the Fortran integer type instead of the C int type. And it's a small thing, but it reduces the cognitive load on your developer. You know, they don't have to worry about 3 languages. They just have to worry about Perl and Fortran. Those are the ones that they care about. The other thing that this does that you can't see is that on some platforms, Fortran actually inserts an underscore in the function name. So, and the foreign language program takes care of that. And the other thing, kind of interesting, not related to this specifically, but in Fortran, the arguments are called by reference, not called by value like they are in C. So when I declare the function, I use a pointer to integer instead of a regular integer, and I pass in references to integers rather than just the integers themselves. Another one that I wrote was a Rust language plugin. Rust is kind of, it's an interesting language. It focuses on safety and giving you grief, making sure that your code is appropriate and safe and stuff like that. So this is just a program that, or a module basically, that it implements points and lines and some code to compute the length of that line. And using the foreign language plugin for Rust, it's pretty easy to use. So again, here I'm using the Rust types, I32 and F64, instead of the C types. This one doesn't handle name mangling, at least not yet. But there's no reason why it couldn't if that were something we decided that we wanted to do. There's also a C++ one, which is actually pretty fancy. It does the name mangling. You can actually create a C++ object and call methods on it without having to worry about, what the actual function name is. It doesn't really make for a very interesting slide, so there's an example library that I wrote called Color FFI that lives on CPAN, if you're interested. So those are kind of the vignettes that I wanted to show, but I also wanted to make a plug for my vision of the future, which involves obviously not flying cars, but flying platypus vehicles, because that would be pretty cool. But actually, I kind of like that chart that I showed you before with Ruby. I think that it would be pretty cool if we had that kind of technology in Perl as well. So imagine if I don't know, somebody forked Perl, or if there was an alternate implementation written in Java, or even it is actually possible to. There's an inline Perl 5 now for Perl 6, and I experimented with actually calling Platypus from Perl 6 using that, and it worked just fine. So you can, in theory, write your bindings in one of these versions of Perl, and expect it to work in multiple different places. So that is mostly it. I'm Graham. I'm on CPAN and GitHub and all those fun things. If you're using Platypus and you're having any trouble with it, let me know. Open an issue on the GitHub. I'm pretty responsive. I'm interested in getting this better and faster and all those good things. Does anybody have any questions? Right. So the question is, how are the types converted correctly or coerced correctly when you pass like a string form of a number into a double or an integer value? Is that? Yeah. It uses under the hood. It uses the same XS conversion macro. I can't remember what it is. So if you provide double quote 1.0 double quote to a function that takes a double, then that will work. So if you pressed a reference to a string that contains a number like that into a function that modifies the value, it actually modifies the thing that's being referred to. So it would come back as a float or an integer instead of a string. So but mostly it's pretty smart, I think. It does more or less the right thing within the confines of keeping it relatively fast. Does that make sense? Anybody else? I mean, I haven't noticed any particular. I mean, it hasn't been. So the biggest library that I have implemented was the libarchive. And that has like 300 some functions, and I implement almost all of them. And in that case, I'm using FFI Raw, but it's completely usable for command line. I haven't noticed any particular latency in terms of that kind of thing. But I mean, you are doing work when you're startup, so it may be a concern potentially. Did I repeat the question? Anyway, okay. Yeah? So the question is, how do you find the libraries, and especially on Windows where that can be problematic. There is a separate module called FFI checklib. It's based on the sort of the devel checklib that's been in CPAN for a while, and it's supposed to do the same kind of thing. It does just fine like the first one in your path, which is more or less what would happen in XS. You could, if you had specific requirements, you could also implement your own and provide the full path to the library. Anybody else? I'll get you. Yes. So the question is, there's an interface for callbacks, and what does the interface for that look like? So when you define the function, it's a little bit different than FFI Raw actually. So FFI Raw, you actually create an object wrapper around a Perl function, which then you pass into any function that takes a pointer. In Platypus, the way it works is you actually define the function type as an argument type. So if the callback takes two integers, for example, you would actually create a type that represents a callback that takes two integers and use that type when you're attaching the function. And then you can actually you can't quite just pass in a Perl subroutine, but you can almost do it. There's a little wrapper that basically attaches the kind of thing that you need, but it's much simpler. There's examples in the documentation if you want to take a look. Anybody else? Oh, I'm out of time? Okay. So thank you. Again, just let me know if you have any questions, or you can contact me on GitHub.